In this video, we're going to talk about the difference between diffusion and effusion, and then we're going to cover Dalton's law of partial pressures. The first word we're going to talk about is diffusion. When we're talking about diffusion, this is the mixing of gases throughout a substance. So if you spray cologne in the air and those gas molecules move throughout and reach your nose, that is diffusion. Effusion is going to be gas escaping through a tiny hole. If you've ever had a balloon before and you notice that the balloon decreases in size, this is because the molecules are escaping through the openings of the balloon. You do need to know the difference. Diffusion is specifically talking about gases spreading. Effusion is talking about gases escaping through a tiny hole. Now the rate of effusion is going to depend on how big the gas molecule is. The smaller the gas particle, the faster it's going to be. So the bigger the gas particle, the heavier it's going to be. And it's all dependent on mass. The lighter it is, the faster it'll move. The heavier it is, the slower it'll move. We're going to go ahead and look at a couple of examples here. First one on here that you're looking at, these gas molecules are moving around. There's an opening in the container. As those gas molecules line up perfectly, they're able to escape through the container. This would be effusion, because the gas molecules are escaping through the opening of the container. In this video, you can see that the gas molecules are both spreading apart. This is diffusion. They're spreading through the container. Now, if you notice on the left side, the NH3, these are moving much quicker. This is because of molar mass. The molar mass of NH3 is approximately 17, while HCl over here is around 36. Because of that, you can see the heavier particle is moving almost twice as slow compared to the lighter particle. When they mix in the middle, you can see that a chemical reaction is happening, and whenever they meet, this is forming ammonium chloride. So diffusion, gases spreading through the container and mixing together. Looking at this example, would this be diffusion or effusion? This one would be effusion because we've got a container with a hole in it, and the gas molecules are able to escape through it. That pretty much covers the difference between effusion and diffusion. What we're going to look at now is Dalton's law of partial pressures. And this is a really easy formula that says the total pressure of a container is equal to the sum of all the individual pressures of the gases within the container. What that means is if you've got three different gases with three different pressures, the pressure of the total container is just going to be equal to all those individual pressures added up together. We're going to go ahead and look at a couple of examples here. The first one on the left, you can see the blue molecules have their own individual pressure, depending on how fast the molecules are moving. In the second container, we're going to have our own pressure here. If we're able to combine these two gases into the third container, the third pressure is just going to be equal to the sum of the first two pressures. Let's go ahead and look at a sample problem. Container A contains a gas under 3.24 atmospheres of pressure. Container B contains a gas under 2.82 atmospheres of pressure. Container C contains a gas under 1.21 atmospheres of pressure. If all of these gases are put in a container D, what is the pressure in container D? Remember, Dalton's law says that P total is equal to the sum of all the individual pressures. So if we set up our equation, container A plus container B plus container C, those three individual pressures, we write those down. We make sure all their units are the same. They are. We add those together, and that's going to be container D. So 3.24 plus 2.82 plus 1.21, and we get 7.27 atmospheres of pressure. One more example. Container A contains a gas under an unknown pressure. Container B contains a gas under 628 millimeters of mercury of pressure. Container C contains a gas under 437 millimeters of mercury of pressure. If all these gases are put in a container D, giving it 1439 millimeters of mercury of pressure, find the original pressure of the gas in container A. Now don't worry about that phrase under pressure. That just means experiencing. So if you see the words under 628 millimeters of mercury of pressure, that just means it's experiencing that pressure. We know container B, we know container C, we know container D. We do not know container A. If we set up our formula, remember P total is equal to the sum of all the individual pressures. Pressure A is our unknown. But if we add that with B and C, and we already know D, which is the sum of all the pressures, then this is a really easy algebra problem where you can just solve for A. If we know B and C, we can add those together, subtract that from 1439, do some simple math, and then our answer for pressure A is 374 millimeters of mercury.